So let's start now. Remote span, or you can also call it rspan. So in previous class we covered local span, and today we are going to cover this remote span. See, the very first thing that you must remember, or you must be knowing, that where to implement this rspan, and also where will be required to configure this rspan. So remember that if you are having like multiple switches in your switched network, in your switching domain, let's say this is switch 1, this is switch 2, switch 3, some couple of switches are also there, switch 4, and finally you are having switch 5. So let's say you are having this switched network here, all switches are connected together. Let's say there is a source behind switch 1 and it is connected on 0 by, let's say, 2 of switch 1, right? There is a user logged in on this host, is transmitting too much traffic and also receiving too much traffic, and now you want to know that which kind of traffic is accessed by this user, which kind of traffic is transmitted by this user, and also which kind of traffic is received by this user. So you want to monitor you just want to monitor its traffic, its data. But the problem is, like this time you are having your monitor server here behind switch 5. Sorry, this is your monitor server. Right? So you will be capturing your traffic on switch 1, but you are required to transmit that traffic towards this monitor server, which is located behind switch 5. So in this case your local span cannot work, because in local span your source as well as destination port must exist on a local switch. But this time you can see here in this diagram that your source is connected to the switch 1, but destination, your monitor server, is connected with switch 5. Understood? So in these type of conditions you will require to configure. That's why its name is remote span. Means that your destination will be located on a remote switch, on a remote device. Fine. So in these type of scenarios, of course, you will always configure rspan. Is there any problem? Have you understood that what is the main difference between local span and rspan? Finally, overall its motive will remain same, because we are using span and rspan just to monitor traffic of users, right? So that's the motive of configuring span as well as rspan. But the thing is, if you are having your source and destination on a common switch, on a same switch, then you will configure span. But if you are having source and destination, your monitor server on different switches, then you will always require to configure remote span. But remember that monitor server is still in a single switched network, in a common switched network, right? Next time I'll be teaching you, next topic is going to be like erspan, right? So at that moment I will let you know that what is the problem with rspan and how can we solve that with using erspan. So this time I hope that you have understood the uses of rspan. So if you are having this kind of diagram, let's say here, what will I do? I'm having switch 1 and also I'm having switch 2. So switch 1 and switch 2 are also interconnected with using 21 and 22. So here and here, you are using 21 and 22 to interconnect these two switches together. Now behind switch 1 you are having some users, like R1 is there. I will be using this router 1 as a end user, R2 is there, then you can also take R3. So R1 0 by 0, I mean each router 0 by 0 is connected with switch 1s, like R1 0 by 0 will be connected with switch 1 0 by 1, it's going to be 0 by 2, and it's going to be 0 by 3. Then behind switch 2 you are having a router, I mean another router, let's say it is R5, and you know very well that R5 0 by 1 is will be connected to switch 2's 0 by 5, and I'll be taking this R5 as a monitor server. I'll be taking this R5 as a monitor server. So this is your monitor server. So this time what I want actually, that if R1 transmits any kind of traffic, see, if R1 is transmitting any type of traffic, it means that here switch port will be receiving that. And if R1 is receiving, I mean if end user is receiving any type of traffic, it means that your switch port will be transmitting that traffic. So the direction of traffic flow will be opposite on switch port and your end user. If switch port is transmitting any data, it means this end user will be receiving that traffic. If end user is transmitting any type of traffic, it means switch port will be receiving here, is not it? So what I want, that if your user is transmitting or receiving any kind of traffic, then it should be captured by switch 1 and should be transmitted towards, I mean in the direction of monitor server. So in this case, I mean in this example, now monitor server is located, is connected to the different switch. So here you will always require to configure rspan. Fine. So whenever you will go for implementing rspan, remember that there will be one dedicated VLAN for rspan, which is known as remote VLAN. You will require a dedicated VLAN to configure, to implement this rspan here in this switch network, and that VLAN will always be known as remote VLAN. So what will you do first? That first of all, create that VLAN. Let's say that VLAN is VLAN 100. I created it on switch 1 as well as on switch 2, VLAN 100, and I'll be configuring this VLAN as a remote VLAN. Remember, this VLAN must be configured as a remote VLAN. And make sure that this remote VLAN is allowed through this trunk port, because if this remote VLAN is not allowed through this trunk port, then remember that your captured traffic will never move from switch 1 to switch 2. See, actually what happens here in case of remote span, that whenever you, let's say that you want to capture traffic received by this switch port of switch 1, which is 0 by 1 here, or transmitted by this switch port, right? So after capturing that traffic, you will require to take it on switch 2. So how can you take this traffic on switch 2 from switch 1? For that purpose, here you will be using this remote VLAN. What will you do here? You will capture, I mean in source of course you will take this interface 0 by 1, and in destination you will put that remote VLAN. With the help of this VLAN, actually this remote VLAN 100, you will take that traffic, that your captured traffic from switch 1 to switch 2. Then on switch 2 again you will define your monitor session, and in source you will define your remote VLAN, and in destination you will define your physical interface. So in this way you will be taking your traffic from switch 1 to switch 2, I mean your captured traffic, your monitored traffic. Understood? So in this way it will work. So let me show you, let me configure all these things now. I have access switch 1, switch 2, then I'm going to access R1. R2, R3 is there, then I will also access R4, and finally R5. This is switch 1, switch 2, R1, this is R2, R3, R5. On switch 1 interface range fast Ethernet 1 by 0 by 19 to 20, and then fast Ethernet 1 by 0 by 23 to 24. I will shut down that because I just want to interconnect these two switches together. Show CDP neighbors. You see, switch 1 and switch 2 are the only switches which are interconnected now, right? But they will not form trunking. So interface range fast Ethernet 1 by 0 by 21 to 22, switch port mod dynamic is array. Now they must form trunking, right? So interface is trunk, that's fine. Show VLAN brief. Let me create some VLANs here. Okay, VLANs are already configured here, and no VLAN 1006, no VTP password, VTP version 2, okay, VTP mode transparent for MST, VTP version 2, that's fine. And in same manner I'll be configuring this switch 2, no VTP password, VTP mode transparent for MST, and VTP version 2. Sorry. Fine. Let's move back again on switch 1 and let me show you. Okay, first of all, enable port fast feature, spanning tree port fast default on switch 1. On switch 2 also enable port fast feature. After enabling port fast feature, let's move on R1 now. On R1, let's allocate its IP address as 10.1.1. On R2, let's allocate its IP address as 10.1.2 so that they can communicate with each other. It's not it. And then we can also move on R3. We can allocate its IP address as 10.1.3. On R4, I will be allocating .4. Whereas R5 will be connected with switch 2. So on R5's F0 by 1, I will allocate 10.1.5. But because of they are in same VLAN, let me confirm it once. Show VLAN brief. Let me show you that whether they are in common VLAN or they are in different VLAN. So here all of them are in same VLAN, VLAN 1, and on switch 2 also they must be in VLAN 1 only. Let me show you. So yeah, they are in VLAN 1 itself, right? So now from R1 you must be able to communicate with all of them, 10.1.2 with 10.1.3 as well, and also with 4 and 5 as well. So you can see that you can communicate with all of them now, right? You are communicating with all of them. Now what I want, that according to this diagram, that if R1 transmits any type of traffic or receives any type of traffic from switch, then it should be captured by switch and should be transmitted out from switch to 0 by 5. Is not it? So this time let's move on switch 1 first of all. To configure it, actually first of all you will require to create a remote VLAN. So create one VLAN, let's say it is VLAN 100, and configure it as a remote VLAN. So remote span, that's the only thing that you need to configure. But here, as you can see, that VLAN 100 is already configured as a private VLAN. So let's do one thing, VLAN 500 and say remote span. So I'll be using this VLAN 500 as a remote VLAN now. In the same manner, you will require to create this VLAN on switch 2 as well, VLAN 500 and say remote span. Now if you want to see that how many remote span VLANs are existing on your switch, the command will be show VLAN remote span. So if any VLAN is configured as a remote VLAN, then it will show you here in the output of this command, show VLAN remote span. Fine. After knowing this thing that okay, we have started to use this VLAN 500 as a remote VLAN, let's confirm it on switch 2 as well. So say show VLAN remote span. So of course VLAN 500 is being used as a remote VLAN now. I mean, for remote span we are using this VLAN 500. After configuring this VLAN 500 as a remote, as a remote VLAN, now let's configure monitor session. Let's configure this rspan on switch 1. So as you know that I wanted to capture whole traffic generated by R1 and also received by R1. So what can we do? That monitor session, let's say 1, and source is what? Fast Ethernet, source interface fast Ethernet 1/0/1, and we can say both because we wanted to capture traffic transmitted by this switch port as well as received by this switch port. And then after you can say monitor session 1, destination is what? Remote VLAN. Which one? 500. That will be your destination, right? So in this way we can define our destination for remote span. So I configured this switch 1 in this manner. So here, as I said, that my source interface is going to be fast Ethernet 1/0/1, and I'll be capturing traffic whether it is transmitted by this switch port or received by this switch port. And then I configure another command here, monitor session 1, and destination will be my remote VLAN 500. So with the help of this VLAN 500, remember that due to VTP pruning, might be that this VLAN will be pruned. I got my point? That due to VTP pruning, might be this VLAN will get pruned. So make sure that if you are using VTP pruning in your switched network, then you must you must remove this VLAN from prune eligibility list. Otherwise this VLAN will become prune, and then after again you can observe now that what can happen in your network if this VLAN has been pruned by your VTP, right? So this VLAN must not be pruned and must be allowed on your trunk port as well. So this time you have configured this switch 1. So after configuring this command, that monitor session 1 destination remote VLAN is 500. So whenever it will capture any traffic on this interface, it will transmit or it will place that traffic for VLAN, in VLAN 500, right? And now VLAN 500 would be allowed through this trunk port. So with the help of this trunk port, it will move on switch 2. And now on switch 2, you will say that monitor session, you can take same number, same session number. However, you can take any number in between 1 to 66. Let's say that here you have taken 15. Monitor session 15 source, and this time source is not going to be your interface. Source will be your remote VLAN, and it will be 500 because this time you will be taking your traffic from remote VLAN, right? And then again you will say monitor session 15, and destination will be interface fast Ethernet 1/0/5 because R5 is connected with this switch port, right? And then yeah, that's what that you need to do over here, right? Monitor session 15 destination interface fast Ethernet 1/0/5. And after configuring this command here on switch 2, means you have configured your remote span, right? After doing this configuration to confirm it that whether remote span is working perfectly or not, what will you do actually? Say clear counters. Now show interface fast Ethernet 1/0/5. So here you must see only and only output packets, is not it? 0 packet output right now.
We didn't mention receive or transmit after 1+0+4.
Oh yeah.
The command monitor session level destination interface.
So why do we require to configure this receive or transmit? Whenever you configure source, then you are only required to specify that you want to capture your received traffic or transmitted traffic only, right? So this time there is 0 packet, of course that must be 0 here. And let's move back again on switch 1. And what can we do on switch 1? Like on switch 1 you don't require to do anything. Do one thing, move on R1, and let's try to communicate with 10.1.2 and repeat like 50 or 100 packets, right? So if you have pinged your 10.1.2 100 times, it means here on switch 2 on its 0/5, it must show me at least to 200. It means this traffic has been transmitted out from this interface. However, we were capturing on switch 1. Actual traffic was going from R1 to R2 via switch 1 only. But due to this capturing, due to configuration of this rspan, now you have taken your traffic your capture traffic from switch 1 to switch 2, and then you have transmitted it out from the switch to 0x5 interface, is not it? And here on this host you will be installing Wireshark, and I hope that all of you knows that how to connect your Wireshark with your physical interface. Like when you open your Wireshark, let's say this is your Wireshark, and then here under interface list you can find your physical interface. So this is your physical interface, you can select it, and then after you will see that it will start to capture all incoming packets, right? So you will simply require to do this thing on your host, which is connected to switch to 0x5. And once again you will see that on switch 2 this interface's line protocol will be down. Let me show you. Its line protocol is down because this port is used for monitoring, and then after you cannot transmit normal traffic via this interface now. Like if you want to communicate with R5 from R1, now it's not possible because you have started to use that switch port as a monitoring port. Now you cannot use that port to transmit your normal data. Fine. So this is the uses of rspan. So I hope that now you can also configure this rspan as well. But remember that in rspan you will be using a remote VLAN. That's mandatory. And remember that remote VLAN must be allowed through your trunk ports. And if you have enabled VDP pruning, then of course you must remove this remote VLAN from prune eligibility list, because you will not be having any member in VLAN 500. So your switches will never ask to their neighbor switches to transmit data for VLAN 500. That's why it is mandatory to remove this VLAN 500 from prune eligibility list from all switch ports, which are actually trunk ports, is not it? So in this way you can configure rspan, and this is the uses of rspan. Now next topic is going to be erspan. However, it is not possible for us to configure here erspan, but let me explain you that what is the uses or what is an advantage of configuring erspan over rspan, or what are the differences in between rspan and erspan. See, in rspan still your destination was available within a switched network, within your own switched network, within a common switched network. But let's assume that here you are having your branch office. Let's say this is your ISP, headquarter is there, headquarter is connected with ISP, one branch office, one is also connected with an ISP. Then after headquarters you are having a switch, and on this switch you are doing some capturing actually, or let's say that in branch office you are having a switch, and then behind switch you are having some users. Now you want to monitor traffic of this user on behind branch office 1, but you know very well that your monitoring server is configured behind headquarters only. Your monitoring server is located behind headquarters. So this time in between you are also having this ISP, your routed network, is not it? In between source and destination you are having a routed network. So now will it be really possible for you to take your captured traffic from branch office 1 to headquarters with using remote VLAN? Because VLAN's information will never go from one branch to another branch if they are interconnected with using an internet connection. So if headquarter and branch offices are interconnected with using an internet connection through ISP, then definitely they will never be able to access their remote VLAN information, right? So this time you cannot achieve this task with using rspan. That is why here we are having erspan. With using this erspan, actually, let's say for an example, you are having your monitoring server in headquarters, but you want to capture traffic of that user which is located in any one of the branch, right? So in that case, because your source and destinations are located in different locations, is not it? And in between those two locations you are having a routed network. So in that case you cannot configure either local span or rspan. In that case, in those conditions, you will always configure your erspan. and right now it is not possible to configure this erspan on all these devices. What can we do? That any one day we can access CCI rack, right? I mean, which is built for CCI preparation, CCI lab preparation, and then we can perform this erspan as well, right? But at least you should be aware that what is the concept behind erspan, and I hope that now you have understood the concept behind erspan. Have you understood it? That where can we implement this erspan? Why do we require to have this erspan? Like, you are having a source, you are having your destination, but in between you are having a routed network. So in between, if you are having a routed network, then definitely you have to configure only and only erspan. Have you understood it now? Let me know. Done? All right. So this is all about span and erspan. And now let's talk about, after going through this after going through this span and rspan, I wanted to perform this practicals of erspan, but these devices do not support erspan. Let me show you actually. Like, for an example, if you are going to configure monitor session, here you will always find like 10, and then you will always find type. Like here, type is not there. Is there? Like, if you configure erspan, I mean, if your device is supporting erspan, then definitely it will support this command as well, because from here you will be defining that, okay, its type is erspan. So you will say monitor session 10 type erspan, and then after you will be configuring all the configuration which is required to configure erspan, right? But first of all, you will require to define your type. Like, I think on routers, you can say monitor session 1 type is also not available on routers as well. So it means on all these devices we cannot configure erspan. In most of the cases, you will find your erspan on Nexus devices, or Nexus switches, or ASR routers. Most of the time you will find configuration of erspan on either ASR router or on Nexus switches. One more thing in erspan, I mean, some properties are also there in erspan, like in a single source. Like, if you are going to configure monitor session 1 source, when we specify a source here either in span or in rspan, then in a single monitor session you cannot call both of them, like VLAN, your VLAN as source VLAN as well as interface. But in case of erspan, you can combinedly call your VLAN as well as interface as a source in a single session. That is also possible in case of erspan. But in case of either span or erspan, you cannot call more than one source in a single session. I mean, you will be calling either interface as a source or VLAN. But in case of erspan, simultaneously you can call both of them. Fine. So that's all about span, local span, rspan, and finally erspan. So next topic is going to be, after covering all these topics, let's talk about protected ports now. Have you gone through MAC table? Like how to create static entries, how to change MAC address aging time? I think we have covered it already, right? So now let's talk about the protected ports, right? Protected ports. There is a feature of protected ports available on your switches, right? Protected ports. It's done?
Yes, sir.
Okay. Then finally, have you gone through the private VLANs? No. So let's talk about private VLAN. Private VLAN. And I hope that if we have gone through the protected port, then you know very well that what are the limitations of protected ports. Like, you cannot define your users in a group with using protected port, because for protected port there is only one rule, that protected cannot communicate another protected. That's it. Apart from that, you do not have anything else. Like, if you are having a group of users in a single VLAN, like if you have divided your users in multiple groups within a VLAN, then it is not possible to control their communication with using protected ports, because in protected port there will be only two things: either they will communicate or they will not communicate. I mean, either you can configure a switch port as a protected or unprotected. You cannot make a group of users with using protected ports, right? So it was a limitation of protected ports. So finally they launched this private VLAN, or you can say that private VLAN is a kind of extended version of protected ports. Like again, you will be using this private VLAN just to manage your intra VLAN communication. Because if you are talking about inter-VLAN communication, then definitely you can control your inter-VLAN communication by using either ACLs or whatever it is, right? You can use a lot of things to control inter-VLAN communication. But if you talk about the intra-VLAN communication, then definitely we do not have we cannot do it with using either ACL or something like that. So for that purpose, you are having here private VLANs. So remember that you will be using these private VLANs just to manage your intra VLAN communication. Let's assume that this is your switch and you are having a department which is HR, and your main VLAN is 100 here. I mean, you have allocated this VLAN 100 for HR department. You understand? Then after, in HR department, you have divided HR executives into two different groups now, right? Let's say these all are executives, but you have divided all these executives into two different teams now, right? This is team A and this is team B. Now you want that team, all users of team A must be able to communicate with each other, and all users of team B must also be able to communicate with each other. But the users of team A must not be able to communicate with the users of team B. And let's talk about, there is a HR manager as well. If you want that the HR manager, this HR manager must be able to communicate with all HR executives, and all HR executives must be able to communicate with HR manager. To achieve this task, now you can implement here private VLAN. You do not have any other option to achieve this task apart from private VLAN, because if you configure protected port, in protected port you have only one rule, which is like either, there will be only two things. If interfaces are protected interfaces, then definitely they will not communicate with each other. But if you are talking about protected and unprotected port, then definitely they can communicate with each other. That there is only one rule exists for protected port, but we cannot achieve this task with using protected port, because if you configure all four interfaces, all four switch ports as a protected port, will it be really possible for them to communicate with each other?
No.
Of course they cannot communicate with each other. Any HR executive will not be able to communicate with another HR executive. So that's not possible with using protected port. You cannot achieve this task with using protected port. So that finally they launched this concept of private VLANs, right? So basically private VLANs are the extended feature of, or private VLAN, the feature of private VLAN is enhancement in protected port itself, right? It is an enhancement of protected ports. So let's talk about now private VLAN. As I said that you will be controlling your intra VLAN traffic with using private VLANs. Intra VLAN traffic, right? So this time, if we talk about the private VLANs, in private VLANs now we are having the concept of primary and secondary VLANs. There would be one primary VLAN. Remember that in private VLANs we are having two types of VLANs. One is primary, another one is secondary. Primary VLAN, your main VLAN, right? Let's say that all of them are existing in VLAN 100, right? So it will be your primary VLAN, and then you will also create some secondary VLAN. When you talk about the secondary VLAN, then further secondary VLANs are divided into two types again. One is community, another one is isolated. Remember, your secondary VLANs are divided into two parts again, community and isolated. So we are having two types of secondary VLANs available in private VLANs, community and isolated. So whenever you will define any VLAN as a secondary VLAN, you will define it either as a community or isolated. Now you must remember the rules behind community and isolated. Like you must remember that by default intra-community communication is possible. I mean intra-community communication is possible. I mean if you are having a group of users, then you can put all of them in a single community VLAN, in a single secondary VLAN, right, so that they can communicate with each other. But remember that inter-community is not possible. Inter-community communication will never be possible. And isolated means standalone. If you talk about the isolated, then remember that the meaning of isolated is what? Stand alone. And the meaning of this standalone is what? They will not communicate with any other user, whether they are existing in any community VLAN or in same isolated VLAN as well. If you are having two users in a common isolated VLANs, then also they cannot communicate with each other. Remember, isolated cannot communicate with community, as well as isolated cannot communicate with another isolated itself as well. Even they will be in same isolated VLANs. If you are having two users in a common isolated VLAN, then also they cannot communicate with each other, because the meaning by isolated is what? Standalone. Now, this is all about your secondary VLANs, right? Next thing is switch port modes in private VLANs. Switch port modes, types of switch port modes in private VLANs. One is host, another one is what? Promiscuous. Alright, so let's talk about switch port modes available in private VLANs. One is host and another one is what? Promiscuous. So you must remember the meaning of host as well as promiscuous. If you are defining your switch port mode as a host, it means that it will be member of secondary VLAN only. It will be member of dedicated secondary VLANs. Like for an example, if you have put your switch port in secondary VLAN 10, it means it will be member of secondary VLAN 10. However, it will remain as member of primary VLAN as well, but it will be member of dedicated secondary VLAN only, right? Let's say for an example, you have put your switch port in secondary VLAN 10, so it will be member of secondary VLAN 10 only. And if you have put it in secondary VLAN 20, it means it will be member of secondary VLAN 20. But if you talk about the promiscuous, it will be member of primary VLAN, as well as it will also be member of all secondary VLANs. If you define your switch port mode as promiscuous, then it will be member of primary VLAN as well as member of all secondary VLANs. So let's prove all these things now. So here I'm having my diagram in this way. Let's say this is switch 1 and this is R1, R2, R3, R4 and R5, and you know very well that all of them are connected with switch 1, is not it? R1 0 by 0, R2 0 by 0, R3 0 by 0, R4 0 by 0 and R5 0 by 0 will be connected with switch 1, right? So R1 0 by 1 is connected with R 0 by 1, R2 0 by 0 will be connected with 0 by 2, then R3 will be connected with 0 by 3, R4 will be connected with 0 by 4 and R5 will be connected with 0 by 5. So in this way all devices will be connected now, right? So what will I do? I will assume that this R1 is working as a HR manager. Fine. And now let's say that these two HR executives are the member of team A and these two HR executives are the member of team B. So this time what will I do? I will create one primary VLAN, and let's say my primary VLAN is what? 100, and then I will configure some secondary VLANs. And under secondary VLANs, because I can have maximum two types of VLANs, either community or isolated. So what will I do? I will create one community VLAN 10, another community VLAN 20, and then if it is required, then you can also create one another VLAN which will be, let's say, isolated VLAN, and it is going to be, let's say, 30. I'll create 3 secondary VLANs. Out from 3 secondary VLANs, one VLAN will be isolated and 2 VLANs will be like VLAN 10 and 20 will be community. And you know very well that intra-community communication is possible, but inter-community communication is not possible. Here I'll put these two users R2 and R3 in community VLAN 10, and these two users R4 and R5 in community VLAN 20. I cannot put them into isolated VLAN 30. You know why? Because if I put R4 and R5 in isolated VLAN 30, then they will not be able to communicate with each other as well. And remember that isolated can also not communicate with another community as well. Isolated is kind of a stand-alone device. It cannot communicate with any other. But remember that if you want that isolated should be able to communicate with HR manager as well, right? Let's say that here you are having one another user which is connected with let's say 0/6 of switch 1, and this is kind of a standalone user, but what I want that it should be able to communicate with HR manager. In that case you can define this this interface as a promiscuous port, because all, whether it is community, whether your user is part of community VLAN or is part of isolated VLAN, can always communicate with a promiscuous port. So I will define this HR manager, because this HR manager is connected with 0/1, so that's why I will define its switch port mode as promiscuous here. So remember, always remember these rules, that community, intra-community is possible, inter-community communication will never be possible, isolated is kind of a standalone, cannot communicate with any other, either isolated VLAN or community VLAN, but it can still communicate with promiscuous. Even remember that promiscuous can communicate with all, whether they are the part of community VLAN or the part of isolated VLAN. I'll also tell you that what are the reasons behind all these things, right? So let me draw this diagram now. So let's do one thing, let's move on R5 once again, and on R5 FA0/1 I'll say no IP address and shut down. FA0/0 I'll say IP address is 10.1.5, right? I have allocated an IP address to this R5 now, and it is again .5. And then after, what will I do? By default all of them can communicate with each other. Like if you are on R2, let's say you are on R2, then .1.1.3 .4, and also it can communicate with .5. Now what I want that R1 should be able to communicate with all of them, whereas R2 and R3 should be able to communicate with each other, but must not be able to communicate with R4 and R5. And make sure that R2 and R3 should also be able to communicate with R1 as well. In same manner, R4 and R5 should be able to communicate with each other, but R4 and R5 must not be able to communicate with R2 and R3. But still R4 and R5 should be capable to communicate with R1. Means R1 must be able to communicate with all of them. That is why I will define this port as a promiscuous port. So let me do this configuration now. So first of all, I will move on switch 1 And here remember that if you are going to configure private VLAN, then your VTP mode must be configured as a transparent. But this condition is applicable only for VTP version 1 and version 2, because during VTP version 3 I have already proved, I have shown you, we saw that we could also configure this private VLAN in VTP mode server as well, but in version 3 only. But this time, because we are running VTP version 2 here, show VTP status, as you can see that VTP version 2 is there, and by default VTP mode is what? Transparent. What can we do? VTP mode, we can say server, but it is already having some private VLANs here. So what can we do? No VLAN 100, no VLAN 10, no VLAN 20, no VLAN 30. Fine. And then after I can say VTP mode is what? Server, but still I think some VLANs are still there. Okay, no VLAN 30. So now VTP mode is what? Server. And then after you do one thing, create VLAN 10 and say private VLAN is what? Because I wanted to configure this VLAN 10 as a community VLAN, right? So this time you can see that what is it saying? Fine. So in VTP mode transparent only you can configure your private VLANs if you are running VTP version 1 or version 2. So first of all, configure VTP mode as transparent here. VLAN 10, say private VLAN is what? Community. Then create another VLAN 20, say private VLAN is what? Community. Then say private VLAN, sorry, then create another VLAN 30, and then say private VLAN is what? And then say VLAN 100, say private VLAN is what? Primary. And then you have to associate all secondary VLANs to this primary now, right? Then after it will come to know that okay, these secondary VLANs are associated with me, right? So you have to say private VLAN association, and then your secondary VLANs 10, 20 and 30. After associating these secondary VLANs to this primary VLAN, now let me show you. Show VLAN private VLAN. So you must be able to see your private VLANs now. So you can see that VLAN, primary VLAN is there, which is 100, 10 and 20, VLAN 10 and 20, secondary VLAN, as you can see here. Primary is 100, secondary is what? 10, 20 and 30. 10 is working as community, 20 is working as community, whereas 30 is working as a isolated. Is there any interface that you have put into these VLANs now?
Yeah.
Is there any interface? No, because under ports you can see that it is not showing us anything. It means we have not allocated these private VLANs membership to any interface, to any switch port yet. Fine. Now let's allocate it. So as I said that R2 and R3 must be in community VLAN.
10.
Tell me. 10. So interface range fast Ethernet 1/0/2 to 3. First command will be switch port mode private VLAN. Now there are only two modes available, either host or. So I have to configure as a on these two interfaces, because I know that via these two interfaces my end users are connected, which are going to be member of community VLAN 10. So that's why I have to take its mode as a host. Once you will configure it switch port mode private VLAN host, you will see that your line protocol of your interfaces will go down immediately. You know why? Because now they are not the member of any access VLAN. They are not member of any VLAN, and if your switch port is not member of any VLAN, it means its line protocol will always go down. So this time, because you have defined its mode is not now switch port mode access, it's not working as a access port now, it is working as a host. Its mode has been configured as a switch port mode private VLAN host. So now without allocating your private VLAN to this switch port, its line protocol will never come up, right? So now say switch port private VLAN host association. This command will be used to associate your VLANs to your switch port. So now primary VLAN, first of all it will ask for primary VLAN, which was 100, and then also it will ask you about secondary VLANs, which was 10. So now these two interfaces have become the member of community VLAN 10.
So all these ports are not a member of by default VLAN 1?
No.
So where is the intra-VLAN communication?
intra, because now they are the member of VLAN 100. Primary VLAN is VLAN 100 now.
The primary VLAN 100. The R2 and R3 is a part of the VLAN 100, and R4 and R5 will be the part of the VLAN 10.
No. VLAN 100 is primary VLAN, which will be for all of them. Primary VLAN means your main VLAN. So if you want to configure inter-VLAN routing, then you will be configuring inter-VLAN routing with using VLAN 100 now. Because for all other users, you are using only and only VLAN 100 for external users which are residing in any different VLAN. So your VLAN 100 is the primary VLAN. Your VLAN 100 is the main VLAN. Within that VLAN, now you are controlling your communication with using isolated and community VLANs, which are secondary VLANs, like 10, 20 and 30. 10 and 20 have been configured as a community VLAN, and 30 I have configured this VLAN 30 as a isolated VLAN. Done? Fine. So now you will see that these two interfaces on switch 1, 0/2 and 0/3, will become member of primary VLAN 100 and also member of secondary VLAN 10. And now you can see that their line protocol have also came up. Then I will move on another two interfaces. Interface range fast Ethernet 1/0/4 to 5. The very first command will be switch port mode private VLAN is what? Host. Once you will configure this command, now it will not be member of any VLAN. That is why its line protocol have gone down. And then after you say switch port association or what? Host association. Primary VLAN which was, and then secondary VLAN which is 20. So again you will see that its line protocol will come up. And then you wanted to configure this one as a promiscuous port, right? So switch port mode private VLAN promiscuous, and then after switch port private VLAN mapping, then it will ask you about your primary VLAN which is 100, and then you will map your secondary VLANs here like 10 and 30. So you have mapped all secondary VLANs to this primary VLAN onto promiscuous port. So now you will see that this promiscuous will become member of all secondary VLANs, whether it is 10, 20 or 30. Let me show you. Show, and now you can also see that line protocol have came up, is not it? So now you can configure this command show VLAN private VLAN. Let me show you now that this 1, 2, 3. See, 2 and 3 are the member of community VLAN 10. 4 and 5 are member of community VLAN 20. However, they are also member of primary VLAN 100, right? But you can see this promiscuous port 1/0/1 is member of all VLANs, all secondary VLANs, whether it is secondary VLAN 10 or it is secondary VLAN 20 or it is secondary VLAN 30. Have you understood it or not?
No, sir.
So,
एक बार theoretical करवा दो, ये सारा समझ में नहीं आ रहा।
so is there any limit to promiscuous port?
What limit?
How many port can we define as a promiscuous port in a switch?
It's up to you. You can define all ports as a promiscuous port, but if you are defining all ports as promiscuous port, then what is the significance of configuring private VLANs? See, let's say I'm having one department here, sales department. There is this department, sales department, and the VLAN is 50. So all the users of sales department are residing in VLAN 50. Fine. This is switch. One user is sales manager actually. Sales manager is connected to this switch. Some executives are there. Sales executive. All are executives, right? Now all of them are communicating with each other because they are in same VLAN 50, and also you are using a common subnet for all of them. 168.50.0/24. Fine. So of course by default all of them will be communicating with each other. Now there is one requirement. The requirement is that now they have divided this team into two parts, team A and team B. Fine. Now what are they required actually? What have they asked to configure? That all users of team A must be capable to communicate with each other, and the all users of team B must be able to communicate with each other, but the users of team A must not be able to communicate with team B. Along with that, you are also having this sales manager, but you also want that this sales manager must be able to communicate with all team members, whether they are existing in team A or in team B. Have you understood this requirement now? So how can you achieve it now actually? Like, forget about private VLANs. Is there any way to achieve this task actually? Like, we are having a concept of protected port, but is it really, do you think so that will it be really possible to solve this problem, to to fix this problem with the help of protected ports only? Is it really possible? Like, there is only one rule, that protected cannot communicate with another protected. So if you configure these two interfaces as a protected port here, what will happen? Even they will not be able to communicate with each other as well, right? But we don't want to do that. We always want that within a team, like within team A, of course they must be able to communicate with each other, but the users of team A must not be able to communicate with the lane users of team B. However, they are residing, all of them are residing in a single VLAN, as well as they are having an IP addresses from common subnet. So for that purpose, we are having here a concept of private VLAN. So if you talk about the private VLAN, here you are having two types of VLAN. One is primary, one is secondary. Primary VLAN will still be your VLAN 50. This is your primary VLAN. Now to achieve this task, actually we will require to create some secondary VLANs. So in private VLANs, you can create some secondary VLANs, and finally you can associate all those secondary VLANs to your primary VLAN, VLAN 50, right? So this time VLAN 50 is going to be your primary VLAN. Understood? This VLAN 50 will be your primary VLAN. So now in private VLANs, you can also configure some secondary VLANs too, like community VLAN or isolated. If you talk about the secondary VLANs in private VLANs, then we are having only two types of secondary VLANs. One is community, another one is what? Isolated. Now there will be two different requirements. Either you will be having a group of users that, okay, this group of users must be able to communicate with each other, and this group of users must be able to communicate with each other, but the users of this group must not be able to communicate with the users of another group. Let's say here we are having this requirement A and B, and might be that you will also require that you will be having some standalone users as well. Standalone. and I don't want to let them to communicate with any other user within that VLAN, within that subnet. Are you getting my point now? So for that purpose here you are having two options here. One is community, another one is what? Isolated. The meaning by community is that intra-community VLAN, intra-community, let's say that you have configured a community VLAN 10, so all users of community VLAN can communicate with each other. So let's say that I wanted that the users of team A must be able to communicate with each other, right? So I will put all these users of team A in same community VLAN 10, in a single community VLAN 10. So I have put them in community VLAN 10. Then I also wanted that the users of team B must also be capable to communicate with each other as well. So what will I do? I will put these two users in community VLAN. Tell me, have you understood it now? Community VLAN 20. And now you know very well that inter-community is not possible. What does it mean? That the users of team A are not going to be communicate with the users of team B. But the all users of team A can communicate with each other, and the all users of team B can also communicate with each other. Fine. Now, it was not necessary to have this concept of isolated VLAN. It was not mandatory. But the thing is, let's say for an example, you are having now two standalone users. You could also achieve it with using community VLAN itself. Like, you could configure community VLAN 30 here, and you could put it in community VLAN 40. And now you know very well that inter-community is not possible. But if you are having 10 standalone users in your VLAN, are you getting my point? If you are having 10 standalone users, you will require to create 10 community VLANs. Is not it? So you could also achieve it with using community VLAN itself. There was no need, there was no requirement of having isolated, but you can achieve this task by using a single isolated VLAN. You will not require to create 10 different community VLANs. Like, you do one thing, if you are having 10 standalone users, create one isolated VLAN and put all of them in that isolated VLAN, because for isolated works same as protected ports. Like, protected cannot communicate with protected. In same manner, isolated cannot communicate with another isolated. Even community as well. So it will become completely standalone. Have you understood it now?
Yes, sir.
So this is, Pradeep, have you understood it now?
Yes, sir.
So this is all about isolated and communities. Fine? Community VLANs. So all these VLANs are secondary VLANs. Finally, all these secondary VLANs are main community VLAN, and your isolated VLANs will be mapped in your
primary.
will be associated with your primary VLANs. Is not it? And I also taught you that in private VLANs we are having two types of switch port modes available. One is host, one is promiscuous. Let's say that I said that, okay, sales manager must be able to communicate with all sales executives, whether they are existing in team A or team B, or they are standalone. Are you getting my point? I said that sales manager must be able to communicate with all executives, whether they are residing in team A, they are existing in team A, or they are existing in team B, or they are standalone. It does not matter. But sales manager must be capable to communicate with all of them. So now what will you do? Here, the interface by which your sales manager is connected, you will define this interface as a, you can configure its mode as a promiscuous port. You can define its mode as promiscuous. Now you must remember that what are the differences in switch port mode promiscuous and switch port mode host. If you define your switch port mode as host in private VLANs, remember that your switch port will become member of that secondary VLAN only, which is configured on this interface. But if you define your switch port mode as promiscuous port, it will become member of all secondary VLANs, whether it is community VLAN or isolated VLAN. It does not matter. That is why now if you move on switch 1, and if you see 1 by 0 by 1, because on 1 by 0 by 1 I configured its mode as promiscuous. So that is why it have become the member of all community VLANs as well as isolated VLAN. And one more thing, for isolated VLAN there is one limitation, that to a single, in a single primary VLAN you can map maximum one isolated VLAN. You can create maximum one isolated VLAN. You cannot create more than one isolated VLAN. You can create more than one isolated VLAN, but you cannot map more than one isolated VLAN to your primary VLAN. Now you can ask that why? The reason is that you will never required to have another isolated VLAN. You will never require to have two isolated VLANs, two different isolated VLANs. You know why? Because for isolated, it means that it is kind of standalone. Because if let's say that you are having here 3 users behind this switch 1 and all of them are in same isolated VLAN 10, will it be really possible for them to communicate with each other? So will there be any requirement to create another isolated VLAN? That is why you cannot map more than one isolated VLAN to your one primary VLAN. In a single primary VLAN you can have maximum one isolated VLAN. If you have understood it, please let me know. Now let's prove it, because I have already configured it, right? So this time R2 and R3 must be able to communicate with each other. R4 and R5 must be able to communicate with each other. R2 and R3 must not be able to communicate with R4 and R5. Are you getting my point? See, R2 and R3 will communicate with each other because they belongs to same community VLAN 10. And R4 and R5 will also communicate with each other because they also belongs to same community VLAN, right? But R2 and R3 will not be able to communicate with R4 and R5. But remember, this 1 by 0 by 1 is part of all VLANs. That is why R1 can communicate with all of them. But make sure that they are having an IP address from the common subnet. They must be having an IP address from common subnet. So let's do one thing. Let's move on R2 first of all. Let's try to communicate with 4, with 3. So it must be able to communicate with 3. But now it must not be able to communicate with 4 and 5. Let me show you. So this is the uses of private VLANs. Even I'm also going to configure isolated VLANs as well. So it's not communicating with 4 and 5. Then you can also move on 5 and you can try to communicate with 4. Of course, it must be able to communicate with 4, right? Because R4 and R5 can communicate with each other, but it must not be able to communicate with 2 and 3. Let me show you. But all of them, all these like R2, R3, R4, R5, all these users can still communicate with R1, and R1 can also communicate with all of them. So you can see that it is not communicating with 2. But if you move on R1, you can try to communicate with 2, with 3, with 4, with 5, whatever. Fine. So in this way, you can configure your community VLANs. Or these private VLANs. Okay, one more thing. Let me configure isolated as well. Let me prove it. That isolated cannot communicate with another isolated, as well as it cannot communicate with another, with community VLAN as well. But it can communicate with promiscuous port. So you do one thing, move on our switch 1. Let's put 4 and 5 in a common isolated VLAN 30. So interface range fast Ethernet 1 by 0 by 4 to 5. Do show run interface fast Ethernet 1 by 0 by 4. So say no, or you can directly say switch port private VLAN host association 130. So it will become now member of isolated VLAN 30. These both interfaces 4 and 5 show VLAN private VLAN. Let me show you. 4 and 5 have become member of isolated VLAN 30. So this time R4 and R5 must not be able to communicate with each other, and also they must not be able to communicate with R2 and R3, but still you will see that R4 can communicate with R1 and R5 will keep on to communicate with R1, because isolated can still communicate with promiscuous. Let me show you now. So if you move on R4, if even previously at least R4 was communicating with R5, is not it? But this time you will see that R4 cannot communicate with R5 now. However, they are member of same isolated VLAN, but still they cannot communicate with each other. See, any problem? Then you can try to communicate with one. You can see that it can easily communicate with promiscuous. In same manner, you can move on R5, and from R5 also you can try to communicate with 4. Of course, it won't be possible for R5 to communicate with R4, but still you can see that it can communicate with R1. And in same manner, it can also not communicate with R2 as well. Isolated cannot communicate with community as well. Fine. So in this way, you can configure your private VLANs. One more thing that I would like to tell you, I taught you these private VLANs in terms of one department. If you are having one internet connection here and which is terminated on R1 is further connected with this switch, and then behind switch you are having some users or some servers, right? Let's say all these servers are behind this R1. These all servers, let's say all of them are in common VLAN 100. All of them are using common subnet, let's say 192.168.1.0/24. Let's say here on gateway you configured 1.1. On these PCs, on these all servers, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7. So in this way you have allocated an IP addresses to all of them, and then after allocating an IP addresses, now actually you know very well that let's say this PC, these two servers are HTTP servers. This is your FTP and this is also FTP. You are using two HTTP server, two FTP servers, and then this is your DNS, and then this is your what? DSCP. So these two servers are standalone, and now what I want that HTTP must be able to communicate with another HTTP only. FTP must be able to communicate with another FTP only. Whereas DNS and DSCP, of course, they are standalone, so they must not be able to communicate with any other server here in this LAN environment, right? However, they are in common VLAN and they are in same subnet. So how will you achieve it? Whereas this R1, because R1 is connected with an ISP, because ISP is there behind R1, right? So of course R1 must be able to communicate with all servers, right? Because users behind internet are accessing all these servers. So this time R1 must be able to communicate with all these servers, is not it? So in this case, now what will you do here? Because on this, let's say R1 0/0 is connected with switch 1 0/1. So of course this 0/1 must be configured as a promiscuous port. You know why? Because this R1 must be able to communicate with all available servers in this data center, or whatever you wanna say. So in this kind of requirement also you can configure the concept of private VLANs, because here what will you do? You will create some community VLANs like community VLAN 10, community VLAN 20, isolated VLAN 30. You can put these HTTP servers in a same community VLAN, you can put FTP servers in a same community VLAN, and then you can put all these DNS, DSCP servers in a isolated VLAN, right? And then after you will get your desired result. Have you understood it now completely? So in multiple cases you can implement your private VLANs. Yes.
Outside traffic is coming.
Okay. When R1 will receive it, R1 will transmit it towards that user, is not it?
Yeah. When a user generated traffic, say a user is coming.
So after going through these private VLANs, let's start PPP. I think this is the last topic of layer 2 from the layer 2 technologies now. PPP, point to point protocol. Let me go through that Excel sheet first. Fine. So first of all, let me configure your voice VLAN now. Let's say default interface range fast Ethernet 1/0/1 to 5. That's fine. So of course they will become member of VLAN 1 now, right? Because by default access VLAN 1 is configured on all switch ports, right? And then after, let me say with no VLAN 10, no VLAN 20, no VLAN 30, and then create VLAN 10 and also create VLAN 20. Let's say that on this interface fast Ethernet 1 by 0 by 1, my access, I mean this port is member of VLAN 10. So you will say switch port mod access switch port access VLAN 10. So now it have become the member of access VLAN 10. But I also want that because this via this switch port you are connected with IP phone as well. Let's say IP phone is also connected to this switch port, right? And then finally IP phone is connected with your end user, right? With your laptop or desktop, whatever it is. But finally, let's assume that IP phone is also connected with this switch port, and you want that voice based traffic should go through VLAN 20. Voice based traffic should go through VLAN 20. I mean, you want to use VLAN 20 for voice based traffic. So for that purpose, you can say switch port voice VLAN is what? 20. So in this case, now you will see that this single switch port will become member of multiple VLANs. Show VLAN brief. Let me show you. So this is 1 by 0 by 1 and this is also 1 by 0 by 1. So this time it have become member of VLAN 10 as well as 20. But 10 is what? Access VLAN and 20 is what? Voice VLAN. Now remember that on a single switch port you can configure maximum 1 access VLAN and maximum 1 voice VLAN. Right? So in this way you can configure voice VLAN. And IP phone will automatically detect that which VLAN is being used for voice. So that IP phone will start to use that VLAN for voice based traffic automatically. Fine. After it, let's talk about smart port macros. Smart port macros, but it is not supported by 3750, so we have to move on. 3550 actually, so it's 3. Switch 3. So we have got an access of switch 3 now, and let's configure it on switch 3. A smart port macro is kind of like, I hope that during CCNP route in BGP you learned about peer group. Okay, forget about that. Let's say there are some commands that you want to configure. On multiple interfaces, right? And all those commands are common commands for all interfaces. So let's say that you are required to configure all those commands on multiple interfaces, so you have to move on each and individual interface and then you have to configure all those commands to reduce your administrative overhead. Just to reduce administrative overhead, you can configure smart port macros. Now if you talk about the smart port macros, we have two types of smart port macros. One is that you learned in CCNP switch, like we can define a port range, interfaces range to a name. We can create a smart port macro to a range of interfaces in this way, like define interface range and its macro name. Let's say macro name is what? Test. Then fast Ethernet 1 by 0 by 1 to 3, and then fast Ethernet 1 by sorry 0 by 1 to 3, and then 0 by, then fast Ethernet 0 by, tell me, like here you took 0 by 1 to 3, then you wanna take fast Ethernet 0 by 5 to 7, then fast Ethernet 0 by 11 to or 11 only, then fast Ethernet 0 by 13 only, then you define it, do show history. So now you have defined a macro name for this range of interfaces. In this range you are having interfaces from 1 to 3, 5 to 7, 11 and 13 only. So now in near future, if you want to configure commands on all these interfaces listed in this range, interface range macro, and then macro name is what? Test. Now say switch port access VLAN 50. Now you will see that all these interfaces will become member of VLAN 50, and these interfaces are 1 to 3, 5 to 7, 11 and 13 only. So now do show VLAN brief. Let me show you that now all these interfaces will become member of VLAN. So in this way you can define your smart port macro for a range of interfaces. Apart from that, you can also say that macro name and then its name, let's say it is Cisco, and then after you can define your commands here inside this macro, and further you can apply this macro under any interface, so that all those commands which you will define here will be applied on that specific interface. Let me show you. Let's say that you want to say switch port. Make sure that spelling should be correct. So switch port mode access switch port access VLAN 50 switch port protected spanning tree port fast spanning tree BPDU guard enable switch port port security switch port port security maximum 1 switch port port security MAC address sticky switch port port security violation switch port voice VLAN 20. Anything else? And then you have to end it with character @ so @ and enter. Done. So you have defined all these commands inside this macro. Now you do one thing, go to an interface like fast Ethernet 1/0/10, sorry, fast Ethernet 0/10, say apply macro apply, and then its name was Cisco. Do show run interface fast Ethernet 0/10. So in these two ways you can define your smart port macros. Have you understood it now? Any problem in smart port macros? So just to reduce administrative overhead, you can define, you can configure, you can create your smart port macros. Okay, then after it, let's go for PPP, because we have covered all other topics now in layer 2 technologies. Is there any topic which is left here according to this? Yeah, there is. Like still we have to go through VSS and CEF. But we will cover it after PPP. Let's go for PPP first, and then after I'll talk about this VSS and PPP. Sorry, this SAF, Cisco Express Forwarding, and that is really mandatory for you to understand the functionality of SAF. However, it is not mandatory for you guys to understand the functionality of VSS. The only and only thing which is required for you to have the theoretical knowledge of VSS, because here you are not having this VSS in your lab examination. You are having it in your written exam only. But SAF is really mandatory in terms of production network as well as in terms of having in-depth knowledge of data forwarding as well. So first of all, let's finish this PPP, and then after we will go for SAF and VSS. Fine. So let's talk about this PPP. What do you know about this PPP actually? Like for an example, of course you must be knowing, you know very well that PPP is an open standard protocol, point-to-point protocol. It is a point-to-point protocol. Second, it is an open standard protocol. Third, it can encapsulate any routed protocol. It can encapsulate any routed protocol. Like at layer 3 you can use any routed protocols. You are having various types of routed protocols such as IPv4, IPv6, IPX, AppleTalk, right? So this PPP can support all of them. And this is not the only feature contained by this PPP. It have a list of features. With using PPP you can perform a lot of things, but here we are going to perform only those things which are required for us to know in PPP on routers. Because with using PPP, of course there are a lot of things that can be performed, but here we will be going through only required things like authentication. Except PPP, any other layer 2 protocol do not support layer 2 authentication. Like if you are implementing PPP as a layer 2 protocol between two devices, let's say there are two routers connected with a serial link and you have configured their encapsulation as PPP, and if you want that without authenticating, their line protocol should not come up. So that can be achieved with the help of PPP only, because any other layer 2 protocol do not support this authentication, layer 2 authentication. But with using PPP you can configure layer 2 authentication, and if your authentication is not done successfully, then then you will see that line protocol of your interface of your link will never come up. This is also one advantage of PPP. Another advantage of PPP is like you can configure multi-link. Like you aggregated multiple Ethernet links. Into a single port channel between two Ethernet switches, right? With using Ether channel. You configured Ether channel, right? At that moment PPP was not required, but let's assume that between two routers you are having multiple serial links. In between two routers you are having multiple serial links, and if you want to aggregate them, then you will require to configure multi-link, and this multi-link is supported by PPP only. So if you are running here HDLC, it means you cannot aggregate them. But if you are running PPP, then also you can also aggregate your serial links as well, which is known as multi-link. So this multi-link feature is contained by PPP only. Then apart from that, PPP also supports header compression. What is the meaning by header compression, and in which conditions we can require to perform header compression? Like for an example, there is too much traffic congestion in your network, right? So you can also compress your data, but PPP supports header compression. It can compress its header information so that there will be less traffic congestion in your network. Apart from it, it is also having a lot of things, a lot of features. Like for an example, you are having let's say this is ISP and this is your customer. Now ISP wants to allocate an IP address to its customer dynamically. That can also achieve with the help of PPP. Like we are using a broadband at our home, even in offices as well. So if we are using broadband, then we are also having one modem over here, I mean at the end of customer, which is, I mean modem is always configured at the end of customer, right? So modem will always get an IP address, will always get a public IP address from an ISP, right? So if modem is getting your IP address, so have you configured it manually ever? Did you configure public IP address on your modem ever by yourself? Of course no, because your modem will get an IP address from its ISP, I mean from ISP, from an ISP router dynamically with the help of PPP. PPP always runs in between modem and ISP router. So with the help of PPP, you can also allocate an IP address to your neighbor device dynamically. Fine. So all these things can happen with using PPP. Even in PPP, it is also not mandatory to perform two-way authentication. Let's say for an example, I want that ISP must authenticate customer, but customer must not authenticate ISP. That is also possible in PPP. It is not like there will always be two-way authentication. It will be up to you that what do you want, whether you want to configure two-way authentication or one-way authentication. So we will be going through all these practicals, and I will show you that you can allocate an IP address to your neighbor device dynamically. Even you will also not required to configure a static default route at the end of customer in the direction of ISP. Like generally at the end of customer we says that IP route 0000 something like that. With using PPP you can also configure this static default route dynamically. So all these things can be achieved with the help of PPP. So these are the advantages of implementing PPP in your network, that you can enhance security of your network with using PPP. Even Ethernet do not have the concept of authentication. That is why here we are having the concept of PPP over Ethernet. Once you will configure PPP over Ethernet, then you can also configure authentication. Fine. So we will be going through all these concepts in in tomorrow's class. Fine. Now it is your homework for PPP that you should be familiar with types of packets in PPP, types of messages, right? Because it will be generating. PPP can generate some types of messages, and also you must be familiar with PPP phases. PPP phases, like it have mainly two phases: link establishment phase and network control phase, NCP. Control phase and link establishment phase. First of all, it performs a link establishment phase, in which it will be establishing link connectivity and also will perform authentication if configured. After completion of link establishment phase, it will move into control phase, which will be performed by NCP, network control protocol, whereas link establishment phase will be performed by LCP, link control protocol. And even LCP and NCP will also be using some other protocols as well to perform their task, like CDP/CP is there, IPCP is there. So just go through the PPP types of messages and also PPP phases.